Hey everyone, today we're going to be learning how to solve integrals, also known as antiderivatives. So, an integral is the opposite of a derivative, and there are many types of integrals. We're going to start off with singular ones and non-complex. So, there is one type called definite integrals. Basically, these ones have bounds, the a and b values. And they're indefinite ones that don't have any bounds. So in the first part of this video, we're going to be learning how to solve indefinite ones. So, the antiderivatives are just the opposite of derivatives. So that means that we use the inverse rules of derivatives. So that means that the antiderivative of something like x to the n would be x to the n plus 1 over n plus 1. Basically, this just undoes any derivative, and you always add the constant of integration, plus c. So, the next rule is the constant rule. Basically, you just attach the variable of integration, or respect, right after it. So let's say we just have the antiderivative of c, or a constant. We just attach the variable of integration. So that'd be cx plus c, uppercase c. So let's try the antiderivative of x squared. So that would be x to the 2 plus 1 over 2 plus 1, which we can simplify to x cubed over 3, which then we can simplify to 1/3 x cubed, and then add the constant of integration. So that would be our answer. Now, let's try one with a multiple. So, what do you think 3x cubed would be? If you want to try that out, pause the video. So, that's equivalent to 3 over 1 times x to the 3 plus 1 over 3 plus 1, which is equivalent to 3 over 1 times x to the 4th power over 4. So if we multiply these, we get 3x to the 4th power over 4, which then we can simplify to 3/4 x to the 4th power and add the constant of integration. Let's try another one of those. What about if we have 5x to the 1st power with respect to x? So it's 5 over 1 times x to the 1st power plus 1 over 1 plus 1. So we can simplify that. 5 over 1 times x squared over 2. So now we multiply it 2, which then we can simplify to 5 over 2x squared plus c. So now, what if we have the square root of x? Well, we can rewrite that as x to the 1/2, and then apply the power rule. So that would be x to 3 over 2 over 3 over 2, which then we can apply the fraction rule, which states that a over b over c is equivalent to a times c over b. So we can apply that. So that means 3 to x over 2 times 2, 3. That means that they're equivalent. So now we can simplify that over 3, and simplify it again. And add the constant of integration. And that's our answer. Okay, let's try another example. What do you think we do when we have multiple expressions in the integral? Well, we can just break them up. So we have the integral of 3x squared with respect to x, and the integral of 2x with respect to x, and the integral of 5 with respect to x. So we can apply the power rule for this one and say it's 3x cubed over 3. So these 3's will cancel, leaving us with x cubed plus c. So we can already add in x cubed. Okay, so now we need to find the antiderivative of 2x, which we can use the power rule on this. 2x squared over 2, and then these 2's cancel out, giving us x squared plus c. But we'll add that in all at the end. Antiderivative of 5. So we can just attach the x here, and we'll have 5x plus c. So our answer is x cubed plus x squared plus 5x plus c. What about if we have something like the antiderivative of 1 over x squared? Well, 1 over x squared is the same thing as x to the negative 2. So, rewriting that, we can now apply the power rule. So, x to the negative 2 plus 1 over negative 2 plus 1. So that equals x to the negative 1 over negative 1. And now add the constant of integration. Let's try another example that has a fraction in it. Let's try the antiderivative of 1 over x with respect to x. So, interestingly, the answer is just an ln x plus c, and that's it. You might have seen this problem somewhere. What's the antiderivative of e to the x with respect to x? Well, if you actually try to evaluate this, you'll end up going in circles. So the answer is e to the x plus c. With that in mind, what's the antiderivative of e to the x plus 1 over x with respect to x? Pause the video and do the problem. So, first thing that we remember is we break it up into multiple parts. So the antiderivative of e to the x with respect to x, that's just e to the x plus c. And the antiderivative of 1 over x with respect to x, that is just ln x plus c. So our final answer is e to the x plus ln x plus c. The definite integral is the area under the curve between the two bounds. What this means is between the x values 2 and 1, the area under the curve y equals 2x is 3. So, a definite integral is the area under the curve at two certain points. So, as we saw earlier, the definite integral has these two bounds, b and a. So, b is the upper bound, and a is the lower bound. What's the antiderivative of 2x with respect to x evaluated at 2 and 1? Well, interestingly, the fundamental theorem of calculus just tells us that we can use the antiderivative that we took, take away the plus c, so it just goes away, and put 2 and 1 and literally evaluate the equations with x plugged in as the upper and lower bounds. So 2 squared minus 1 squared. And that literally gives us the area under the curve. How neat is that? Let's try it. So that's 4 minus 1. That's 4 minus 1, which is 3. And as we saw earlier, the answer was 3. So the area under this curve between 1 and 2 on the equation y equals 2x is 3. Okay, this is a practice problem. What's the antiderivative of negative x cubed plus 3x squared plus 1 with respect to x evaluated at 3 and negative 1? The area under this curve is 12.